Welcome and welcome to Cambridge Chemistry channel with sarwatahmed. Be sure to like the video and subscribe. It really helps the channel to grow. Today I will be solving paper 22 of Feb March 2021. Let's start. The rate of chemical reaction is affected by change in temperature and pressure. Draw a curve on the axis to show the Boltzmann distribution of energy of particles in a sample of gaseous krypton atoms at a given temperature. Label the curve T1 and label the axis. Label the curve T1 and label the axis. Over here, number of particles or molecules with energy, and on x-axis is energy. This is T1, On the diagram A1, draw a second curve to show the distribution of energies of krypton atom at higher temperature. Now this is T2. This is activation energy, and this is activation energy at higher temperature. So no need to mention over here, just describe this diagram. So this is activation energy and this is activation energy A. So molecules with lower energy and a higher temperature molecule with higher energy. But he asked you only label the second curve T2. So at high temperature, this is the curve of T2 at higher temperature. The Boltzmann distribution assumes that the particles behave as an ideal gas. State 2 assumption of the kinetic theory as applied to an ideal gas. State 2 assumptions of the kinetic theory as applied to an ideal gas. Collisions between particles and walls of container are elastic. mean no gains and no loss of energy during the collision between the particles as well as with the walls of container. Elastic means no gain and loss of energy. Second, there are no intermolecular forces, between the particles. 2 gram of krypton gas is placed in a sealed 5 dm cube container at 120 degrees centigrade. Calculate the pressure Pascal of krypton in the container. Assume krypton behave as an ideal gas. Mole of krypton is 2 gram divided by krypton AR is 83.8. The moles are 0.0239. Now temperature is 120, so temperature should be in Kelvin. 120 plus 273, that is equal to 393 Kelvin. Now by applying PV is equal to nRT, P is equal to 0.0 239 into 8.314 into 393, like P is equal to nRT over V. So the volume is 0.005. So we know that 5 dm cube and volume should be in meter cube, like 5 into 0. So this is in meter cube. So 5 decimeter cube divided by 1000, which is equal to 0.005 meter cube. Now after calculation, the answer will be 15,600 Pascal. State and explain the conditions at which krypton behaves most like an ideal gas. So there are two conditions at which gases behave like an ideal gas, like that is high temperature and low pressure. So at high temperature and low pressure, there is insignificant volume of the particles. And at high pressure temperature and low pressure, gases behave like an ideal because there are high temperature and low pressure gases behave like an ideal gas. uh, like there is insignificant volume of the gas as compared to the volume of the container, and there is insignificant intermolecular forces between the particles. Krypton reacts with fluorine in the presence of ultraviolet light. Krypton plus fluorine to form krypton fluoride. Activation energy is this. Enthalpy change of krypton fluoride is plus 60.2. Use the information to complete the reaction profile diagram for the formation of KrF2. Label EA and delta HF on the diagram. Assume the reaction proceeds in one step. This is endothermic reaction, as delta H formation is endothermic. This is activation energy, and this is enthalpy change, delta H. Reactants over here, products. Explain terms of activation energy and the collision of particles, how an increase in temperature affects the rate of a chemical reaction. Particles have more kinetic energy. Increase in temperature affects the rate of chemical reaction. Particles gain kinetic energy and more particles will have energy more than activation energy, more than activation energy. So frequent, so there will be more frequent collision between the particles, make reaction faster. Particles makes reaction rate of chemical reaction faster. Question number 2. Chlorine is a reactive yellow-green gas. It is a strong oxidizing agent. State how chlorine is used in water purification. Disinfectant used as a disinfectant or kills the germs in water. Chlorine, we can write down, chlorine is used to kill the germs in water. Chlorine has the highest first ionization energy of the period 3 elements. Sodium to chlorine. Construct an equation for the first ionization energy of chlorine. This is chlorine in gaseous state. When 1 mole of electron is removed from gaseous atom to form positive ion, 1 electron. So this is equation of the first ionization energy. Explain the general increase in first ionization energy of the period 3. Explain the general increase in first ionization energies of the period 3 elements. It increases due to increasing nuclear charge, same shielding effect, and decreased atomic radius. All these factors contribute the general increase in first ionization energy. Next question is the halide ion where X is equal to chlorine, bromine and iodine show clear trends in their physical and chemical properties. State and explain the relative thermal stabilities of the hydrogen halide. Stability of HX is decreased down the group due to increasing the shielding effect and increasing the bond length, which increases the bond length. Hence attraction become weaker between HX bond, so less energy is required, so less bond energy, less energy is required to break the bond. To break the 1 mole of bond. So you can say simply bond energy, bond length increased down the group, and bond energy is decreased downward. Next question is the main sulfur containing the halide ion reacts easily with concentrated sulfuric acid. The main sulfur containing products of each reaction is shown in the table. HSO4 main sulfur containing product reaction with sulfuric acid and bromide with iodide. Oxidation number of sulfur. HSO4 is equal to -1, where +1 plus x, sulfur is assuming as x, oxygen 4 minus 2 is equal to -1, so 1 plus x minus 8 is equal to -1, x minus 7, x is equal to -1 plus 7 is equal to 6. So this is +6. Sulfur dioxide 2 2s are 4 and POFLA 4 plus, and similarly -2. So this is +6 plus 4 -2. Complete the table, show the oxidation number of sulfur in each of the sulfur containing products. Explain why different sulfur containing products are produced when each of these halide ion reacts with concentrated concentrate containing products are produced when each of these halide ion react with concentrated sulfuric acid. Complete the table. Explain why different sulfur containing products are produced when each of these halide ions react with concentrated sulfuric acid. As we know that when it reacts with sulfuric acid, react with chloride ion, its oxidation state is +6, and oxidation state is going to decrease as we move down. It means reducing power increases down the group. Reducing power increases down the group due to more shielding and ionic radius is due to more shielding and ionic radius make easier to lose electron. Chlorine reacts with aquasodium hydroxide in disproportionation reaction. State what is meant by disproportionation reaction. It is the reaction in which one species is oxidized and reduced at the same time. Write an equation for the reaction of Cl2 with cold aqueous sodium hydroxide, chlorine plus sodium hydroxide to form NaCl plus NaClO plus water. So this is the cold, and this is also very important to hot concentrated. So that is chlorine, sodium hydroxide. So in this reaction chlorine is oxidized over here -1 and over +1. So oxidized and reduced at the same times. NaCl in hot, NaClO3 plus water is formed. Aluminium reacts with chlorine to form aluminium chloride. Aluminium chloride can exist as the gaseous molecule Al2Cl6. This molecule contains these molecules contain coordinate bonds. Draw a diagram to clearly shows all the types of bond present in Al2Cl6. This is the structure of chlorine, aluminium, Cl, Cl, and Cl. So this is lone pair. And this is another molecule, aluminium. This is lone pair. Or coordinate dative or dative bond or coordinate bond. Describe what you would see when solid aluminum chloride reacts with water. Solid aluminum chloride. Name the type of reaction that occurs. This is AlCl3 plus water to form Al2O3 plus HCl. So 3H2O and 6HCl. Now to AlCl3. Name the type of reaction. The type of reaction is hydrolysis. 0.020 mole of element Z react with excess chlorine to form 0.02 mole of liquid chloride. The liquid chloride Z formula has ZClN, where N is an integer. ZClN reacts vigorously with water at room temperature to give an acidic solution and white solid. When excess AgNO3 is added to the solution, 11.54 gram of AgCl formed. Suggest the type of bonding structure with the ZClN. Suggest the type of bonding and structure shown by ZClN. So this is covalent bond. The liquid chloride has ZClN. Reacts vigorously with room water at room temperature to give an acidic solution. If white and a white solid, ZClN reacts vigorously with water at room to give an acidic solution and a white solid. When excess silver nitrate is added to solution, 11.54 silver chloride is formed. Solid form. Suggest the type of bonding, the structure shown. So acidic solution is formed, so it is chloride of non-metal, so the bonding is covalent. Calculate the value of N in ZClN. Okay, Z reacts with chlorine to form ZClN. So there is 0.02 mole Cl2. So this is ZClN. ZClN. So there So we know 0.020 mole of Z reacts with chlorine to form 0.020 mole. It means 0.020 equivalent to 0.02 mole. So for in next statement, ZClN reacts vigorously with water to form acidic solution and a white solid. When excess silver nitrate is added to the solution, 11.54 gram of AgCl forms. So we can find out the mole of ZClN by using this reaction, because when ZClN react with AgNO3, it forms silver chloride. So we have the mass of silver chloride. Zn. This is Z only, not zinc. ZClN. So we can predict the mole of ZClN by finding the mole of silver chloride, ZnO3. Mole of silver chloride is equal to 11.54 divided by 35.5 plus silver is 107.9. So the moles are 0.08. So now, which is equal to, because over here 1:1, 1:1 ZClN, oh my god, ZClN ratio silver chloride, that is 1:1, and 0.08 ratio X. So the moles of 0.02 N is equal to 0.08 mole, and N is equal to 0.08 divided by 0.02, which is equal to 4. So the mole of Cl and number of Cln is 4. The answer is 4. So this is SiCl4, which react with water to form acidic solution like SiCl4. When react vigorously with water to form white solid SiO2 plus HCl acidic solution. So it is further react with excess silver nitrate to form 11.54 gram of silver chloride forms. Dichloromethane is widely used as an organic solvent. CH2Cl2 can be prepared by reacting CH3Cl and Cl2 at room temperature. The reaction proceeds via several steps as shown. Cl2 to form two free radicals. This is free radical CH3Cl. This is propagation 1, propagation 2. And in propagation 1, that this free radical make methyl chloride free radical and form HCl, and CH2Cl now make chlorine molecule to form products. CH2, this free radical make chlorine free radical, again propagation 2, and in final step that the two free radicals form one product. Give the name of mechanism of this reaction. This is free radical substitution.
Three, give the electronic configuration for
Ultraviolet light, UV light or sunlight, you can write down, and give the electronic configuration of chlorine radical, free radical, 1s2, 2s2, 2p6, 3s2 and 3p5, and identify the products of the step labeled propagation 2. Propagation 2 is free radical chlorine plus CH2Cl2. So this is CH2 and Cl2 is added. Then name the type of the reaction shown in the final step. This is termination step. So there are basically three steps in the free radical substitution: initiation step, propagation, and then termination. Suggest the identity of another organic molecule that is a product of the reaction of CH3Cl and Cl2 under the same condition. CH3, Cl and Cl2. This is CHCl3. We can write down. Question number 3. Compounds P, Q, and R have all been found in the atmosphere of one of Saturn's moons. P is this, Q is this, and R is this. The equation for the complete combustion of PC4 N2 is shown. C4N2 plus oxygen to form carbon dioxide and nitrogen. The enthalpy change of formation of delta HF of carbon dioxide is minus 384 kilojoule. Calculate the enthalpy change of formation of delta HF of P in kilojoule of P. Combustion of P is shown, C24N. So this is C4 C4N2 plus 4O2 to form 4CO2 plus N2. Delta H is minus, carbon dioxide is minus 384, and this is 2036 minus 2036, and we know that the formation of P carbon, nitrogen and oxygen. So this is the elements form, and this is formation of carbon dioxide is minus 384, and this is carbon dioxide is minus 384. Delta HF in kilojoule formation of, calculate the enthalpy change of formation of P. So we have to find out P. So this is P, and we make two roots. This is starting point, this is starting point, and make this ratio like this, and this is this. So P is delta HF, P plus delta HR minus 2036. This is root 2, this is root 1, and is equal to minus 384. So delta HF is equal to delta HF of P is equal to minus 2036 is equal to minus 384. Now delta HF is equal to minus 384 plus 2036. Sorry, this is multiplied with 4 . This is into 4, so that is into 4. The answer is 4 into the answer is, let's calculate 4 into 384 is equal to 15 minus 15, 36 plus 20, 36. So the answer is minus 15, 36 plus 20, 36 is equal to plus 500. 500 kilojoule per mole. One of the products of the complete combustion, P is gas. Explain the lack of reactivity. Due to strong triple bond between two atoms of nitrogen. Q forms when HCN reacts with ethine. Ethine, HCN and Q are all weak Bronsted-Lowry acids. What is meant by the term weak Bronsted-Lowry acid? Weak Bronsted-Lowry acid is proton donor. Acid is proton donor, and if it is weak acid, so not completely ionized in aqueous solution. Ethine, HCN and Q all contain triple bonds between two atoms. The triple bond consists of 1 sigma and 2 pi bond. Draw a label diagram to show the formation of 1 pi bond. This is sigma bond between nitrogen and nitrogen, and this is pi bond. Let's use another color. This is pi bond. This is pi bond, or in other words, you can we can show this like this. This is pi bond. P and Q can be detected in the atmosphere by infrared spectroscopy. Identify two absorption and bonds that correspond to these absorption that will appear in the infrared spectra of both P and Q. P and Q. Q is carbon to carbon triple bond, and P is nitrile bond. So it's carbon to carbon. Two absorption are C triple bond C is at 2150 to 2250, while second bond is nitrile and absorption is 2200 to 2250. So these are the two bonds. Next question is flow chart shows some reactions of our reaction 1. This is addition polymerization. And dilute H2SO4, and the compound is CN is hydrolyzed, so the compound is CCH H and CO2H, and this is the name. The type of reaction is addition polymerization. And draw the structure of S, the organic product of the reaction 2. Organic product of the reaction 2. So this is CaCH and CO2H, and name T is propyl 1 amine. Propyl 1 amine. T can also be formed by the reaction of CH3, CH2, Br2 with ammonia, bromopropane with ammonia. State the necessary conditions of this reaction. Ammonia dissolved in ethanol. Ammonia in ethanolic medium. And condition is heat under pressure. Question 4 is hexa. Hydroxyethanol has been observed in dust clouds near the center of our galaxy. Predict the bond angles labeled X and Y. Bond angle in X is 104.5, while at Y, because it is trigonal planar, this is tetrahedral geometry, so 104.5 and 120. Hydroxyethanol reacts with separately 2,4-dinitrophenyl hydrogen and with Tolan reagents. State what you would. This is ethanol, and reaction with 2,4 D, it converts into orange precipitates, and with Tolan reagent silver mirrors. Hydroxyethanol is converted to a thin dioic acid when it reacts with excess acidified dichromate ions. State the role of acidified chromium. So, chromate ion act as an oxidizing agent. So, in this reaction, it act as an oxidizing agent, and condition is heat under reflux. This is common condition. Now, in the use H to represent an atom of hydrogen from the reducing agent. So this is C2H6O2, and the reagent reagent for this reaction is for this reduction is NaBH4. CH2OH twice also forms when an alkene reacts with cold dilute acidified potassium. A cold is dilute acidified manganate ions. So this is ethene. Like when it react with cold, H when it react with cold dilute KMnO4, then it forms OH, sorry, H and H, which is further oxidized to form C double bond O, OH, C double bond O, OH. So the name of alkene is E. Hope you will like the video. Please subscribe and like this.